All right, so this is going to be the review for Earth Science 106. There you go. First up, stars are really big and exert a lot of gravity. I mean, if you think about it, the Earth has enough gravity to hold all 8 planets and Pluto in orbit, plus all the asteroids and comets and dwarf planets and so forth and so on. So they have a lot of gravity. And you might ask, well, why don't they crush themselves then? Well, stars don't collapse for most of their lives. Maybe at the end of their lives they do, when they can no longer sustain fusion. See, fusion is where the nucleus of one atom fuses with the nucleus of another atom and they become a bigger atom. And this releases a ton of energy. It powers every star in the universe. And so the stars don't collapse because gravity is balanced by the force of nuclear fusion. And that keeps the star from collapsing on itself. Now, when the stars run out of fusionable material, then gravity starts winning and they start collapsing. And they might become a like a white dwarf, or they might become a really big stars, might supernova. All right. So we have the core, and around that we have the mantle. And the mantle is, we describe it as plastic. Now, we don't mean it's made out of plastic. We mean that it's similar to plastic in the sense that it can bend and flow a little bit. Some people might call it semi-molten. And so what happens is you have this ridge, or these tectonic plates. Let's say this is Africa, maybe that's North America or something. And they're moving along on top of this mantle because of the convection inside the Earth. If we have overgrazed soil, the plants are going to die, and then wind will be able to blow that soil and dust into the air, and that can lead to dust storms. All right. This is data. So we have years going here from 1930 to 1990, and here we have 50 feet below the surface to 100 feet below the surface. So we can see over the decades that the water is getting deeper and deeper. So then the question is, why is the water getting deeper? Well, it could be that there is an increase in water being pumped out, maybe for irrigation, maybe for a new mall, who knows? But there's some reason, maybe, that there's an increase in pumping water out of the aquifer. Another possibility is that there was a decrease in recharge. Maybe there was a decrease in precipitation. Okay, so these are possible conclusions from this graph. If we have acid rain, okay, aluminum compounds, the acid in the rain can react with aluminum compounds in the soil and free that aluminum and then carry it into lakes and rivers and streams. And as it builds up in lakes, it can actually harm wildlife. So while some environmental changes might be good, some environmental impacts are bad. So the takeaway is that all environmental changes have an impact. Now, it might be good, it might be bad. In this case, it's bad. This is a weather question. I know we didn't get to weather this year, but here we have Tornado Alley. This is supposed to be the United States. I know it's not a very good drawing, but it's supposed to be the United States. In the middle, we have Tornado Alley. You know, Dorothy lives right about there. And what happens is we have warm, moist air, probably from the Pacific Ocean, and we have cool, dry air, probably from up north somewhere. And when they meet in the middle, And when that happens, you'll get storms. And if the storms are severe enough, they could be thunderstorms. And if there's enough energy in that storm and a rotation starts, you can actually end up with a tornado. And since these two air masses tend to meet in the middle of the US, and the middle of the US is pretty flat, relatively speaking, that's where we have a lot of tornadoes. Um, so if we have a river flowing down to the ocean, uh, a delta will form where the sediments settle at the mouth of the river. And that delta can build up. It can be farmland, it can be soil, people live on it. For thousands of years, humans have used deltas as part of their civilization. However, in modern times, deltas are shrinking in some places. They're not uh, being built up the way they used to, and part of that is dams. Humans build dams to provide power, to provide drinking water, and to provide um, other things. But they build like hydroelectric dams or just flood control dams. And climate change is another reason that the deltas have changed because weather patterns change. Um, and so there may not be enough rain uh, flowing into the river to carry sediments to the delta. Um, if we were comparing deserts, forests, grasslands, and tundra, deserts are going to have the least amount of vegetation, and forests are going to have the most amount of vegetation. Um, so what I was showing here is if you had a field of corn and you harvest the corn and you sell it, by selling the corn, you're losing nutrients from the soil because the nutrients in the corn came from the soil. So every time you send it away, you're losing nutrients. So if you plant the corn over and over again and constantly, plant the same crop, you're you're going to run out of nutrients, and so you're going to end up with less fertile soil. And that's it for Earth Science Review 106. I will see you in class. Have a good day.